third case, sometimes okay, the same integral is repeated. The same integral or integrals, same integrals are repeated. Same integrals are repeated. Same integrals are repeated in the right hand side. Same integrals are repeated in the right hand side. In the right hand side, then that repeated, okay, integrals, that repeated integral, that repeated integral is transposed to the left hand side, and added or subtracted to the original one, then the answer of original can be found out. Okay, I'll just take an example of this. In integral is transposed to the left hand side, and then after addition or subtraction to the original integral, the value of the original one can be obtained. It can be obtained after dividing or multiplying the right hand side, okay, to get the original one. Can be obtained through by division or multiplication to the right hand side, by division or multiplication to the right hand side of the coefficient of the original integrals. Okay, so original integral value or integrals. Original integrals, whatever is there, that value can be calculated by dividing the coefficient or cross multiplying by the divided coefficient of the original value to the right hand side. In this way is the third method. Now it has been found, let me write here, given and is to be integrated with the help of bypass method. So one is considered. Now let me talk about that how these functions are to be considered, first and second function, which I have already discussed about. That method is applied, that formula is applied, and we can find out first and second function here. So that we will apply. Okay, so there are three methods here, and how we can find out through inspection or through formula. Through inspection we have discussed about. Now in this case, mostly what do we find out? Let me take the fourth point here. Fourth point here, okay. The algebraic functions which are, let me write here, which are decreasing in degree after differentiation are considered as first function are considered as first function. Are considered as first function. Okay, so this is the fourth point we have discussed about. So mostly algebraic functions are considered, therefore they are decreasing because their degree is decreasing. So finally that will be eliminated and the one function will be remained. And mostly the repeated, okay, the repeated example let me take here. If I take that e raised power x on cos x, let me take sin x into e raised power x. This kind of function is given. Now in this case, the repetition will be there. This is the original integral. Now in this case, this is a repetition example. If we take a repeated example, or in case of the repetition, okay, repeated example. If I take here ex and sin x, simply let me take this. So this will be how it will be integrated. Or let me take here twice x, or it is sine 2x. Let me take here. It is nothing but sine twice x, okay, into e raised power ax. Let me take this function. Now this is bx. Sine bx into bx. Now which function is first and which is second? That we have decided, but for this is e logarithm exponential function, which is ILATE in the ILATE, which is ILATE. The last one, the second function is the first function. Okay, so we can integrate this applying the bypass method here. This is product of two functions here. This is repetition. In this case, I'm just going to show you that how repetition is done, and then the repeated part is to be taken into the left hand side, transpose to the left hand side, and finally after addition or subtraction, whatever coefficient of that original function is there, we divide by that coefficient to the right hand side, or sometimes we multiply by the, if it is in the division or in the denominator, if it is, then we can get this repetition. So this is a repetition example. We will take these questions here. This is the question here. This is the question which is repetition type. Okay, and mostly this is not repeated. Okay, so this is the repetition type. These two are repeated, and others, if there is, just find out them, and when after solving them, this is the repeated one, 31st. Okay, this is a repeated one. Okay, not others. So whatever is repeated, I'll just talk about that. Sometimes some functions are not repeated. Okay, so we will discuss about them. So after solving them, so this question is repeated. Let me take this example here, how we can do this integration. This is second function, this is first function, sine bx as it is. Okay, into e raised power ax is e raised power ax, this is integration upon a minus sine. This is for integration, sine of integration, differentiation of sine bx, this is cos bx into b. Okay, multiplication. So in case of differentiation, we multiply by the coefficient into e raised power ax upon a into dx. Now this function is still not repeated. Second time again we have to differentiate 1 upon a. This is sine bx into e raised power ax minus sine. This is b upon a. Okay, sine of, again this is combination of two functions. We have to apply that bypass method here. Sine of integration. Let me write it in bracket. It's cos bx as it is. Again, this is the first function. This is the second function. Integration of this will be eax upon a minus sine integration. Now cos bx is what? Minus sine bx differentiation. This will be sine bx into b. Okay, into e raised power ax upon a. Further it is repeated. This is same function which we have got sine bx into ex, but coefficient is there minus b upon a, and this is sorry sine bx, and here it is plus sine bx. We can take this value this side. Let me first solve it. So minus b upon a into b upon a square, or a into a, into cos bx into e raised power ax. Okay, with this is minus sign, plus sign. So This is b square b upon a square here. A square sine of integration. This is sine bx. Okay, into e raised power bx into dx. Now this function is a repeated one. The same integrable value or integrand is obtained. Okay, so we have to just transpose this to this side. We will get here, this is plus sign. Here it will be with minus sign. Minus b square upon a square. Sine of integral, this is sine bx into e raised power ax into dx. Okay, so this now is being transposed to that side. So this function is removed. What is the final answer? After solving this is a square minus b square. If we solve it further, this is a square minus b square. Taking LCM into b square, sine of integration sine bx into e raised power ax into dx. The sum of these two. Okay, this is difference. This value is the coefficient here. Now we have to find out value of this. So this can be calculated. This can be found out by cross multiplying this, taking b square here, this whole value, this one, and sorry, these two. So this we have solved like this. These two are here. So this will be, let me write here, 1 upon a into sine bx into e raised power ax minus sine 1 upon b a square into cos bx into e raised power ax. Can be written as e raised power ax, okay, upon a square. If I take LCM, it will be a here, within bracket it will be a into sine bx, okay, minus sine b into cos bx, this value. Now this is to be multiplied by this. Therefore, sine of integration, this sine bx or e raised power ax into sine bx into dx is equal to b square, this, okay, b square e ax upon a square minus b square. This is a square minus b square, within bracket the whole value, a sine bx minus b cos bx. This is the final answer here. So we have seen here that if repetition happens, that like this function is repeated, then this is to be transposed to the left hand side, and then the original value and this value are added together, and the coefficient is taken to that side, and the value of this is found out. So this is how the process of repetition happens. Okay, so other examples we will talk about, but let me take now the questions one by one. Okay, so all of these things, if there is any special thing, I'll repeat or repeat it there. If I remember, then I'll just discuss about that in between when the questions are being solved. Now let me take the questions one by one. So this is the process of by parts method. Okay, what we have discussed about the formula which we have applied here, that has been just found out by students, very useful. So that I'll take here also, I will use that also here. So in this way, we will be able to solve these questions, and with the help of these questions, we can get mastery over the questions of other kind. Okay, I'll take step by step this topic so that the student can get mastery over the subject. So now let me take the questions one by one. Now questions, important questions. Let me take the marker is not working. So this duster. Okay, so duster, let me clarify here. Duster, sorry. Okay, now let me take questions one by one. First question, in this case, sine of integration x e raised power x into dx. Which one is the first function? Which one is the second? We know that exponential function is the second function, the last one. X is the algebraic function. So ILATE formula, this let me write here. ILATE formula, ILATE or ILATE formula. ILATE, LAT, late, and I'm sorry, why I have written 8 two times. I'm sorry. Let me write again. ILATE. This is the formula which we have to apply here. I means inverse function, trigonometric inverse function. L, this logarithm function, algebraic function, trigonometric function, exponential function. Now here we have algebraic function x and E exponential function e raised power x. This is in the same series, first function, second function we have to consider. So This x is considered as the first function. This is the second function. Simple. This formula also. So what is the integration? Applying the bypass method. Applying or by the bypass method, we can write here applying the bypass method. Bypass method. We get this whole is equal to tan, or let me write here e raised power x, or simple x into e raised power x into dx equal to x, the first function as it is, into integration of second dx minus sign ddx of differentiation of first into integration of second whole integration. So what we get here? Integration of ex is ex, nothing else, minus sign this. Now sign of differentiation of x is 1. This is 1 into only ex here. This is the integration of ex. Ex, which I have written here, this is 1 into ex. Differentiation of x is 1. Ex into dx. Further, let me write here this x ex minus ex, the integration is ex only. Okay, and plus constant of integration, because this is indefinite integral. Alright, so constant we can write here. Constant. Now from these two we can take ex common. This is x minus 1, this constant of integration. This is the answer here. Therefore, this x ex is equal to this value. This is the main part. Ex into x minus 1. This is x minus 1. This integration of this function by using bypass method. Very important formula in this. Okay, so this is the first question we have done. Let us talk about the second question. And using the same bypass method. So second question here. What does the second question say? So this is sine of integration x into sine x into dx. Again, x is algebraic function, sine x is trigonometric function. So ILATE, ILATE, t then. So t comes later. T comes later, a comes before. This is first function, and this is second function. So taking, using or applying bypass method. Okay, using bypass method. Using bypass method, we get the sine of integration x into sine x dx is equal to x, the algebraic function first as it is, integration of sine x, integration of second function minus sine of integration ddx of again x, the first function, into integration of sine x into dx whole dx. Integration of the two, the product of two. So this is x into sine x is minus cos x. Integration of sine x is minus cos x below. Indefinite integral. This is minus sine, again it will be plus sine. From this it will be cos x negative. It will be 1 here into cos x into dx. Integration of sine x is minus cos x, it is minus 1 becomes plus. Now again this is minus x cos x. Now integration of cos x is 1 into cos x is cos x. Integration of cos x now is plus sin x plus constant of integration. Finally, this is the answer here. Okay, this is the answer, final answer. Therefore, this equal to minus x cos x plus sin x, and this is the answer here. Okay, question number second we have done. Now question third, let me talk about sine of integration. This is log x only. Now in this case we have to discuss about, so whenever there is single function and we have to apply the bypass method. In this case, why bypass method is applied? Why? Because we cannot find out integration of this function is not integrable. This note, let me discuss about the forgot about discussing this. When there is single function, okay, I discussed about this also. That log x tan inverse x, which cannot be integrable. These functions are not integrable. Integration of this cannot be calculated, cannot be found out. So we have to consider 1 in the multiplication of this as the second function. In this case, we will consider it as 1 as second function to log x as first function into 1 into dx. As I discussed about that, 1 is taken as second function for integration. Why for integration? Because 1 can be integrated. If it is differentiated, then what it will be 0. The whole value will be 0. Then what is the use of that? So that is 1 is for second function for integration. So let me. This is the first function log x as it is. Integration of 1 into dx minus sign of ddx of log x. Dx of log x into integration of 1 into dx whole dx. Okay, integration of these two. So from this is log x. Integration of 1 is x, so let me write x log x minus sign. This is x here, sorry, 1 upon x. Differentiation of log x is 1 upon x into this is x here into dx. So again this x extension out. This is minus sign 1 into dx only. So x log x is equal to this is minus 1 only. So this is log of x minus x. Integration of 1 is x here plus constant of integration. So this is the answer here. To answer our third question is this: x log x minus x plus c. Which question is taken as first function, second function? Apply this formula, which is mostly I have found applicable. Okay, so this is just for those students who can't decide which function is to be considered as first and second. Just think about this: inverse trigonometric functions, logarithm function, algebraic function, trigonometric function, exponential function. This I have already put it down in the introduction part. Okay, so definition part. Now let me take the fourth question here. Now question number 4. Sine of integration, this is x square log of x into dx. So what we have to do? Now in this case again, logarithm function, whenever there is no confusion that x square is also decreasing because x square is differentiated. I discussed about that if other functions are given, you have to consider as first function. No. In this case, log x will be considered as first function because integration of log x will be known. The formula is also say LA log the function first function, algebraic function second function. This is second function here in this case. This is first function. Try to understand. Logarithm function is first function in this series. First, second, first, second, first, second. Whatever functions are there, any combination of two functions out of this in the same series, first, second, we have to consider. This is the first function here, logarithm function. Second function is algebraic function from that formula. Let me write here. So this will be log x, let me write first, and x square second. This implies that this is equal to now log x as it is. First function as it is. Integration of x square into dx minus sign of ddx of log x into integration of x square into dx whole dx. Because integrate, we have to integrate the product of these two obtained values. This is log of x into x cube upon 3 minus sign. What is differential of log x is 1 upon x into integration of this is x cube upon 3 into dx. 1 x is cancelled out. So this is 1 upon 3 x cube log x minus sign. Here it is only x square 1 upon 3 out. X square into dx. Further it can be integrated as log x minus 1 upon 3 into x cube upon 3 plus constant of integration. This is 1 upon 3 if I take common, and x cube is also common. It will be log x 3 log x or 9 if I take, then it will come as 3. So let me take 9 common. 1.9 common if I take then 3 log x minus 1 only plus constant of integration. So this is log x cube. So 3 into log x, it will come here. And x cube I have taken common. Okay, so this is minus 1. So this is the answer. Here we can write here 3 log x cube. Okay, minus 1. Or can be written as 1 upon 9x cube into this is log of x cube minus 1 can be written like this also. Plus constant of integration. This is also the answer. So either of these two is the answer. This is question number 4th we have done. Now let's talk about what is the next question, 5th one. Question number 5th. This is on the target of bypass method we are discussing about. Very important topic this is. We have to discuss this now. So question number now 5th one, what does it say? And question number 5th here, sign of integration. This is x square into cos x into dx. Again the same formula. ILATE is an algebraic function, trigonometric function. T comes later. Algebraic function, trigonometric function. First is algebraic function. The same routine. This is first function, this is second function. We can write like this. Therefore, this will be equal to. Let me apply the direct formula. First function as it is, integration of cos x into dx minus sine ddx of first function is x square into integration of cos x into dx whole dx. Okay, so this will give us x square integration of cos x is positive sin x minus sine. This is twice x here. Differentiation of x square is twice x. Cos x is sin x here. So here repetition of the product root, bypass method. Again x sin x is obtained from the same formula. X is algebraic function, trigonometric function, same order. This first function, second function. The minus 2. Let me apply here. Let me repeat that. This is sin x. And if this x into sin x, again apply the bypass method. X function as it is, integration of sin x. Let me write the formula here. ddx of x, which is of x, sin of integration sin x into dx whole dx. Okay, so this is the repetition of bypass method. Twice x, it will be integration of sin x is minus cos x. This is minus cos x here. Minus minus plus it will be. It is x is 1 into cos x into dx. Why positive? Because minus integration of sin x is minus cos x. Minus sign will become positive. So again, let me integrate this. This is minus minus plus here. Plus sin twice x cos x. This is minus sign here. Okay, so minus 2 into this 2. Cos x is sin x integration positive. This constant of integration. So here x square sin x is equal to. So this is the answer here. You can take 2 common, no problem, and can be written as the same answer. So the sin x is common from these two. No need of that. This is the answer here. Therefore, 5th question has this answer. These two functions can be added, or these two can be added just like taking 2 common. Okay, this is sin x common from these two only. Okay, so then that can also be summarized. This is the answer. Can be written the same answer. Okay, so this is question number 5th we have done here. So let's talk about next question, 6th one. Question number 6, what does it say? So bypass method we are applying here. We are using bypass method to solve these questions. Now question number 6th, sign of integration. Answer. This is Ex into cos x. This is a repetition type of question. Here there will be repetition because Ex and cos x both are integrable, but they cannot be eliminated. They may be repeated after second or after second part. Okay, so this is first function, second function, which Ex exponential function, the last function. E is the last. The second function, this is the first function. First and this is second. Same rule we can apply. Or in this case, no need of first and second because the question will be repeated again and again. Okay, so any one can be taken as first, second in this case, especially in this case. But we have to apply this formula, then this is the process. Let me talk about this. So cos x as it is, integration of Ex into dx minus sine ddx of cos x. okay, into integration of Ex into dx whole dx. This is nothing but cos x into Ex. Integration of Ex is Ex, e raised power x, exponential function. Same integration is there. This is now differential of cos x is plus. I mean, it will be negative. It will be sin x. Now integration of this is integration of, but we are writing differentiation of cos x inside. That will be minus sin x, which is positive sign. Integration of this is Ex only into dx. This dx is here. Now again apply. This is repetition of by parts method. We have to apply this first. Next again, this is the first function, second function. Now sin x as it is into integration of dx minus sin. Now differentiation of sin x into integration of Ex into dx whole dx. Okay, let me write this also. Ex into cos x, sorry. Ex into cos x. Let's sign this. So let me write it again. Ex into cos x plus sin x into Ex. Because integration of Ex is Ex minus sin. Here, what the differentiation of this will be cos x. Sin of integration it is cos x. This is Ex only into dx. Now we see that this function is repeated. The same integral or same this function or integrals we have, or integrand which we started with, we have obtained the same function here. It is repeated one. We can transpose this to this side. Okay, so this will be transposed to this side. If we take this right hand side, left hand side, so we will get here twice, because this will be added to this. This is minus sign, this is plus sign. Both will be added. The same function is added. It will be twice sign of integration Ex into cos x into dx. Now what is the left one? The left function is this only. This is Ex. If I take common out of these two, we will get sin x plus this is sin x plus cos x. Okay, so therefore integration of Ex into cos x into dx is equal to 1.2. This 2 will come in the denominator here. Ex within bracket sin x plus cos x. Okay, plus constant of integration we can write here. This is indefinite integral.